All right, we're going to talk more today about writing equations in slope-intercept form. So, here we go. Remember, y equals mx plus b. M is the slope, and b is the y-intercept. Knowing that, we can determine the slope and the intercept just from an equation of any line. We just look at those points. So m is 3, and b is minus 5. And there we go. So here, slope is 7 over 6, and the y-intercept is 3 over 4. For the next one, slope is negative 4 over 5, and because there's no intercept listed, then we say it's 0. Okay? This one has slope of 4, y-intercept of negative 7. And then we have a slope of 2/3. Again, no intercept listed, so it is 0. This one is y equals 5, so it's like saying 0x plus 5. So my slope is 0, and the y-intercept is 5. What does that look like? If we have a graph, and it would just be 1, 2, 3, 4, 5. So it would just be a line right here at y equals 5, horizontal line. So that's 0 slope when it's horizontal. If we have the equation, then we can also, if we have the slope and the intercept, then we can generate the equation. Y equals 2/3 x minus 5. Next one, y equals 1/2 x, and then plus 0. If m is 0, again, it's just y equals negative 2. It's a constant. For this one, y equals 3x plus 5. Y equals 2/3 x minus 6. The next one, y equals 0x. The slope is 0, so it's just y equals 4. Moving on, y equals 1/2 x, and then it's plus 0. Next one, we can say y equals negative x. We don't have to write negative 1x, because when the coefficient is 1, it's understood to be there. And our final one would be a bear to graph. Y equals negative 7 over 8 x minus 4 over 5. That would be a tough one. Okay, we can also look at data in a table and figure out what the equation is, all right? So again, remember the first thing you check is on the x's, are they all the same difference? Okay, as I move from each one, this goes up 1 each time, okay? So it is all the same. Now we look at the y's, if it's all the same. The y's go up by 2 each time. So in fact, it is linear. If I wanted to find the slope, I know slope is the change in y over the change in x. So in this case, that's 2 over 1. So my slope is 2. For the y-intercept, it's not listed in the table, but I know if I followed things up, I could see that I'm at 0.6 for my x. So my intercept is at 0.6. So the equation is simply y equals 2x plus 6. Okay? If I have a graph, I can figure out what the equation is just from the graph. All right? Just like we always want to pick our y-intercept first, I can see it's at 5. So my y-intercept is at 0.5. Next, I want to find a point where it crosses my grid line, okay? So any point where it crosses any of the grid line right there. So we look for that, and I can see that it crosses the grid line here, it crosses the grid line there, and again there, and again there, and again there. So picking any two of those points and just counting squares as I go over and up, I can see that I go over 3 and up 2, so my rise over run is 2/3. And because this is going up to the right, it is positive 2/3. So then my equation is y equals 2/3 x plus 5, just like that. Okay, now if we have, excuse me, my finger's not working to move this around. If we have the equation, then we should be able to generate the graph. Again, looking at the equation, my intercept is at 0, 7, and the slope is minus 1/2. So what I want to do is, on my graph, I'm going to go to 0, 7 first, and put a dot, and now my slope is negative 1/2, so I'm going to go down 1 over 2, so right there, down 1 over 2. And I can do this forever and ever, down 1 over 2. And then I'm just going to do my very best to connect those points with a straight line. And there we go. That is the graph of y equals minus 1/2 x plus 7. Last one today, graphing 3x minus 1. The intercept is at minus 1. The slope is at 3. All right, so let's see. Here's my intercept at minus 1. I go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. And then I'm just going to draw a line through these points. And that is that. All right, thanks again for following along with the notes. We'll see you more next time.